So today's skill is you could factor polynomials that are what I call quartic trinomials. That means that there are three terms. First power quartic, that means to the fourth power. And so we'll have three terms. The first term will be to the fourth power. And I'm also going to show you how to factor some other higher degree polynomials. So today is factoring. It's really nothing new, and you'll see that here in a second. And so what I'm going to be using is these notes right here. We're going to work through basically around 10 problems, maybe not all of them, but I will show you how to factor quartics. So let's go ahead and get started here. So here's that page. And there's a couple ways I could show you this, but I'm just going to get straight to the point. And straight to the point is, if you have a quartic and there's three terms, 1, 2, 3, and it follows this pattern, 4, 2, constant, then you could actually factor it just like a quadratic. And so let me show you what I mean. I'll show you what I mean just on the first problem. So let's say we don't know how to factor x to the fourth. So let's let a equal x squared. So we're creating a new variable. So what that would mean is x to the fourth would be x squared squared. So I could write this as, you know what, if I show this method, I think it's just going to confuse you. Yeah, I'll show you. So if a is x squared, we would get a squared, because x squared squared is x to the fourth. And then if a is x squared, we'd get minus 2a. And then I would factor that. Remember, a is 1, and I shouldn't have used a. But we're going to multiply to -8, but add to -2, because this is a quadratic, and we know how to factor quadratics. So what multiplies to -8, but adds to -2? That'd be -4 and 2. Okay, so then I would have a minus 4, a plus 2, just like we did in quadratics, but wait, a is equal to x squared. So this would be x squared minus 4, and that'd be x squared plus 2. So really, what I usually do is I skip all of this, and I just put x4, and I go ahead and make the factor x. I'll show you that on the next step, but I wanted to show you where this came from. Now, x squared minus 4 factors, that's difference of 2 squares. So that's going to make x plus 2x minus 2. And if you're asking, where did you get that? We have been covering difference of 2 squares already. Anytime you have a perfect square and a perfect square, you do x and x, 2 and 2, and you do 1 plus, 1 minus to get rid of the middle term. Now here, remember that if there's a plus, that it makes an I if this is a square. And 2 is not a square, but there is a trick to do this. So I would say, I would go x, and I would recognize that square root of 2 times square root of 2 is 2, and recognize that when there's a plus, that you get an I. So this would be x plus I square root of 2, x minus I square root of 2. Because square root of 2 times square root of 2 is 2. And remember, when there's a plus here, you need the I. All right, so that may have just confused you, but I'll show you some more examples. right, the next one is still in the form 4, 2 constant. I'm actually going to skip the a equals x squared step just to make it simpler. And what I'm going to do is if it's 4, 2 constant, you could actually go ahead and start with the x. And so then you'd put the 6 on top, 7 on bottom. And then we need two numbers that multiply to 6, but add to 7. I know. Oh, 6 and 1. 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. And so normally you would put x plus 6, x plus 1, but because it's a quartic and you're separating that out into 2x squared, it's going to be x squared plus 6, x squared plus 1. Now, if I wanted to, I could check my work. X squared times x squared is x to the 4th. X squared times 1 is 1x squared. 6x squared, that'd be 7x squared right there. And then 6 times 1 is 6. So if you distribute this, you do get that back. Another way you could check your work is you could type this in Desmos, type that in Desmos, and you should get the same graph. Now we're not done. So this is a plus, so it's going to have an I. This has a plus, so it's going to have an I. And then we can't take the 6 is not a perfect square, so we're just going to write that as square root of 6. But 1 is a perfect square, so we're going to write that as 1. 1 times 1 is 1. So when I do this, I'm going to get x square root of 6i, and this one's going to be x with the 1i. And why is there an I? Because of this plus. So I'd get x plus I square root of 6, and then x minus I square root of 6. And then for the plus 1, because 1 times 1 is 1, if you take the square root of 1, you get 1. So we don't need to put square root of 1, we can just put 1. So it's going to be x plus 1i, x minus 1i. And there we are. All right, let's do the next one. So really, it's all the same thing over and over and over. We have 4, 2, constant. I'll use a different color to make it look different. So when it follows that order, I need to find two numbers that multiply to -2, but add to -1. Let me think. Multiply to -2, but add to -1. -2 and 1. And then again, you can only do this if it goes 4, 2 constants. And so we're going to break this into x squared minus 2 and then x squared plus 1. And you could distribute it out if you're not sure. Now, the minus, remember when there's a minus, we do not put an I. When there's a plus, we do put an I. But 2 is not a perfect square, but there's a way around that because square root of 2 times square root of 2 is 2. So you're going to put x plus square root of 2, x minus square root of 2. And notice that there is no I. If that was x squared plus 2, we would have an I here and an I there. Now x squared plus 1, square root of 1 is 1. So, I mean, we just did this one. It's the same thing. It's going to be x plus 1i, x minus 1i. And we're done. It's in factored form. Okay, now if we wanted to solve these, which we are not solving until the next unit, then I would say negative square root of 2, positive square root of 2, negative 1i, positive 1i, but we are not solving yet until the next unit. So you can see the next unit is going to be easy if you understand how to factor. All right, now this one looks a little different. It is a quartic, but it is not a quartic trinomial. It's a quartic with a constant. So anytime you have a quartic with a constant, you could actually factor it just like you do difference of two squares. Because in fact, x to the fourth is a perfect square. 36 is a perfect square. So when I write this out, x to the fourth, I could write as x squared and x squared. And then the 36 is a perfect square. That's 6 times 6. So I'm going to put plus 6, minus 6. Okay, and notice it's a minus, so we do not have any i's. And then from here, because I have plus 6, and 6 is not a perfect square, so we'll just write that as square root of 6, and the plus will make an I. So for this part, when we factor that, we'll get x plus square root of 6, x minus square root of 6. And because it's a plus, we need that I there. And then here, it's going to be the same thing. So it's still going to be x plus square root of 6, x minus square root of 6. But because it's a minus, we do not need to put an I out front. And so if someone said, what are the solutions? You'd say negative I square root of 6, positive I square root of 6, negative square root of 6, and also positive square root of 6. So I found 4 solutions. Notice it's to the 4th power. So it's supposed to have 4 solutions. 2 are real, 2 are imaginary. Okay. So far, I have shown you how to factor when it's 4, 2 constant, and how to factor when it's 4 constant. So today is pretty much all about the quartic. All right, another one. So this one is a 4, 2 constant. I put the negative 27 on top. I put the negative 6 on bottom. And then I think what multiplies to negative 27 but adds to negative 6. And I'm pretty good with multiplication, but it still takes me a second to think. Negative 9 and 3. Negative 9 and 3. Negative 9 times 3 is negative 27. Negative 9 plus 3 is negative 6. So I'd break this into x squared minus 9, x squared plus 3. The negative is going to have, it's going to make real factors. The plus is going to make imaginary factors. Now 9, 3 times 3 is 9. And this is difference of 2 squares. So I'll put x3, x3. One with the plus. One with the minus. And because it's a minus, you do not have an I. If that was x squared plus 9, this would be 3i minus 3i. Now x squared plus 3, I'm going to break this into x, and then 3 is not a perfect square, but there's a shortcut. We could say square root of 3 times square root of 3 is 3. So I'll say x plus square root of 3, x minus square root of 3. And because there's a plus, now if this was a minus, this would be correct. But because this is a plus, you need that I there. So this quartic has 4 solutions. It has negative 3, 3, negative I squared of 3, positive I squared of 3. So 2 real, 2 imaginary, for a total of 4. Okay, another example. In this case, I need to actually move everything to one side before I factor. So I'm going to subtract 81 from both sides. And then I notice that this is a 4 constant. So it's difference of 2 squares. So I'll break this into x squared, down into 9 and 9. And because there's a minus, I don't need an I. So it'd be x squared plus 9, x squared minus 9. But let's see, 9 is 3 times 3. So this is going to be x plus 3, x minus 3. And because there's a plus, I need the I. And then x squared minus 9 is also x plus 3, x minus 3. And because there's a minus, you don't need the I. So we're done. So the solutions are negative 3i, positive 3i, negative 3, positive 3. But again, we're not doing the solutions just yet. All right, I know these are quite a few examples. I don't know if we're going to go through every single one, but the more you see, the better. All right, number 5. 4, 2, constant. Actually, let me see. Yeah, we can just keep going. 4, 2, constant. So I'm going to find 2 numbers that multiply to negative 45, but add to negative 4. Multiply to negative 45, add to negative 4, negative 9 and 5. Yes, that'll work. Negative 9 and 5. And remember, because this is a quartic, I'm going to put x squared minus 9, x squared plus 5. Now for x squared minus 9, it goes x plus 3, x minus 3, no i's. And for x squared plus 5, that's going to be x plus I squared of 5, x minus I squared of 5. Remember, anytime there's a plus, you put an I. And 5 is not a perfect square, but square root of 5 times square root of 5 is 5. So that's kind of a short way of doing that, shortcut. All right, let's see. Another one. What multiplies to 6 adds to 7? Well, that'd be 6 and 1. So I'll write this as x squared plus 6 x squared plus 1. Notice you do not have to make the factor x if you don't need to. What multiplies to 6 adds to 7 would be 6 and 1. Now, they're both pluses, so they're going to both produce imaginary factors. So this has 4 imaginary solutions, or complex, another way to say that. So x squared plus 6 is going to be x plus I squared of 6, x minus I squared of 6, and then x squared plus 1 is going to be x plus 1i, x minus 1i. I remember I had a question last year when I was teaching, why did you not put square root of 1? Here you put square root of 6. Why didn't you put square root of 1? Well, square root of 1 is 1. Okay, so I think that's important to say here too. Lots and lots of examples. Number 7. What multiplies to negative 10 but adds to negative 3? Negative 5 and 2? Yeah, that works. Okay, so then I put x squared minus 5, x squared plus 2, and you may have noticed I haven't been putting equal 0 because we're not solving these yet. Okay, so I figured there's no point in putting that down. So from there, this is going to be a real solution, no i's. This is going to be the one with an I because that's a plus. 5 is not a perfect square, so we're going to put square root of 5. So we're going to say x plus square root of 5, x minus square root of 5. And then for x squared plus 2, I'm going to put x plus square root of 2, but with an I because of the plus. And also x minus I square root of 2. And then again, next unit, the solutions are negative square root of 5, positive square root of 5, negative I square root of 2, positive I square root of 2. This one has 2 real and 2 complex, making 4 total. Now you might be looking at number 8 going, that looks absolutely nothing like what we've been doing. And this has 4 terms. And just looking at the time, we're going to do a whole day like this. There's nothing on your practice like this. But anytime you have 4 terms, what you do is you break it in half and you factor both sides. I'm trying to decide if I want to show you that or not. It's not on your practice, but it's a good preview. So I guess I could do it real fast. You break this in half, and again, you may not understand this part, which is okay. And you look and you go, okay, what does this have in common? It has an x squared in common, so you factor out an x squared, which leaves x plus 2. And then pull down your negative. And you look at those, what does 15x and 10 have in common? They both have a 5 in common, so I take out a 5. This one's not going to work. Oh, I forgot the 3. X times 3x is 3x cubed. Oops. But when I take out a 5, 5 times 3x is negative 5 times 3x is negative 15x. And then negative 5 times positive 2 is negative 10. And again, this is just a preview. I don't expect you to understand number 8. So then they both have a 3x plus 2, so you take that out. And and you get x squared minus 5. And then from there, this is already factored because it's a linear factor to the first power. And then this could factor in x plus square root of 5, x minus square root of 5. And then I bring down 3x plus 2. This is a skill called factoring by grouping. Again, you probably don't understand that yet. That's fine. We'll spend a day on that when we come back from break. All right, I really wasn't planning on going through all 10, but we do have time. And I think the more I show you, the better. And these don't take very long, as you can see. Multiply to 18, add to 11. I think through 9 and 2. 9 times 2 is 18. 9 plus 2 is 11. So then I do x squared plus 9. And then x squared plus 2. They're both pluses, so they're going to produce 2 complex and 2 complex. So that's 4 complex. So this one has no real solutions. This is going to make x plus 3i, x minus 3i. And then x squared plus 2 is going to make x plus I square root of 2, x minus I square root of 2. And if you're thinking, why did you not put square root of 9 here? Well, square root of 9 is 3, so I went ahead and reduced that. All right, our last example. Notice all I need to do on this one is move the 12 over. So I subtract 12 from both sides, and I get x to the 4th minus x squared minus 12. And again, I'm not worrying about the equal 0 because we're not really solving these. And I need to find two numbers that multiply to negative 12 but add to negative 1. That's going to be negative 4 and 3. So then I get x squared minus 4. And then x squared plus 3. This is going to produce 2 real factors that are real solutions. This is going to produce complex. Okay, so this one's going to make x plus 2, x minus 2. And then x squared plus 3, I need the I, and square root of 3 times square root of 3 is 3. So this is going to make x plus I square root of 3, x minus I square root of 3. So notice I have 2 real solutions, negative 2 and 2. And I have 2 imaginary solutions, negative I square root of 3, positive I square root of 3. All right, I know that was a lot. I don't usually go over 10 examples, but I just wanted you to see this multiple times to kind of get you guys in the practice of factoring what's called quartic trinomials when it goes 4, 2, 4, 2 constant. The practice, notice all it says is factor, so you're not solving. So you do not have to solve. The first one is 4 constant. We did an example like that in the notes. Whereas number 18 is 4, 2 constant. Some of these you need to put in order first. So you need to bring the negative 21x squared over and put that in the middle. So this is what you're supposed to do for practice. But other than that, that's all I have. I hope you have a great day, and I'll see you later.